Welcome to Math with Professor V. This is video lecture for section 1.2 for business calculus or brief calculus. And in this video, we're going to go over linear functions and applications. Now, in the previous lesson, we went over the equations of lines, and we always had y in terms of x, right? Well, now we're going to replace y with f of x. And you might say, why in the world are we doing this? Well, f of x gives us a lot more information than just writing y equals. F of x now says that y is a function of x. It's dependent on what we substitute in for x, and it can let us know precisely where each y value came from. We can see what x was responsible for that output y. So let's practice a little bit of function notation. Hopefully it's a little bit of a review, but if not, that's okay. I'll link some videos in the description where I break down more examples with function notation if you need more practice. So here, let f of x equal 3x minus 5. We're going to find f of negative 2, f of 0, and f of 3. So notice, to find f of negative 2, I'm literally going to come right here, replace x with negative 2, and then I have to do the same thing on the other side. I'm going to replace x with negative 2. F of negative 2 is 3 times negative 2 minus 5. And then just clean up. 3 times negative 2, that's negative 6, minus 5 is negative 11. So basically what this is saying is, when I substitute in negative 2 for x, the y value, or the function value, is negative 11. So when you see f of negative 2 equals negative 11, you should be able to translate in your brain that that means the ordered parent negative 2, negative 11 is on the graph of the function. If I were to just come up to you, say we're walking down the street and I'm like, hey, y equals negative 11. You're like, okay, that's great, but I don't know, where did that come from? What did we plug in for x? I have no clue. But if I tell you instead f of negative 2 is negative 11, then you have a lot more information, okay? That's one of the reasons. There's many why we use function notation. Okay, let's continue. F of 0 would be 3 times 0 minus 5. What would that be? 0 minus 5, right? Negative 5. And then f of 3, 3 times 3 minus 5, that's 9 minus 5, so 4. What if I asked you for f of star? Yes. 3 star minus 5. Very good. Okay, let's continue now. So last lesson, we looked over equations of lines. Now we're going to talk about them as functions. A linear function, a relationship f defined by y equals f of x equals mx plus b for real numbers m and b is a linear function. So what are the key things to look out for to make sure you have a linear function? You have y in terms of x, and x is only to the first power. That's the exponent on the variable, okay? Very good. Like I said, we were looking at y equals mx plus b last lesson. Just think y got a makeover. Now it's f of x. All right, moving on to supply and demand, which we'll be studying throughout the remainder of the course. The supply is the quantity of a certain good that producers are willing to provide. The demand is the quantity of the good that consumers are willing to buy. And the law of demand states that as the price of an item increases, consumers are less likely to buy an increasingly expensive item, and so the demand for the item decreases. So there's an inverse relationship here. As price goes up, demand goes down. The law of supply states that as the price of an item increases, producers are more likely to see a profit in selling the item, so the supply of the item increases. So in this case, you're looking from the producer's perspective, and if price is going up, I want to supply more. It's going to be more profitable to us in the long run. So let's see how we're going to build on these ideas here. First example, suppose that the demand and price for strawberries is related by the following equation. So price is given by this demand equation, which is a function of Q. Q is the quantity, and it's equal to 6 minus 0.25 times Q. You should know that this is a demand equation anyways because of the minus sign in front of Q. So the slope is negative. And we just looked earlier that demand tells us that as price increases, demand decreases. So it would have a negative slope. Okay, anyways. So P is price in dollars, and then Q is quantity demanded, and Q is in hundreds of quarts. So find the price when the demand is 0 quarts, 400 quarts, and 840 quarts. And we're going to put units on everything. So here we need the price when demand is 0 quarts. So price, I'm going to substitute in 0 for Q into the demand equation. And we have 6 minus 0.25 times 0. So that's just going to be 6. And I'm going to put units on it, dollars. Now, we're just going to repeat this process. Remember though, quantity Q is being measured in hundreds. So you're not going to substitute in 400. When they say 400 quarts, you're just going to substitute in 4. Oh, that's better. That won't be such a large number. So D of 4 would be 6 minus 0.25 times 4. 0.25 times 4, that's just 1, right? If you have 4 quarters, you got $1. So 6 minus 1, this is $5. And then 840 quarts, just divide by 100 or move the decimal place over 2 to the left. That's the demand for 8.40 or 8.4. So 6 minus 0.25 times 8.4, can get your calculator out. You should get $3.90. Okay, good. So we're substituting in demand quantity and finding the price. Now we're going to go the other way around. So find the quantity demanded for the strawberries at $4.50 and $3.25. So we're going to substitute these in for P. So $4.50 equals 6 minus 0.25 times Q. I'm going to subtract 6. So you have negative 1.50 equals negative 0.25 Q. Divide by negative 0.25, and Q is 6. But when we report our answer, remember this is, Q represents hundreds of quarts. So that's 600 quarts if strawberries are priced at $4.50. Okay, let's repeat for $3.25. Why don't you pause the video, try it on your own. I hope you paused it. Make sure you can do it without me, you know. I won't be there when you take your test, sadly. Okay. So 3.25 equals 6 minus 0.25 Q. Subtract the 6 over 3.25 minus 6. You should have negative 2.75 equals negative 0.25 Q. And Q equals 11. But remember, when we report our answer, we say 1,100 quarts. Does this follow the law of demand? Yes. Price went down, demand went up. Makes sense, right? If something's cheaper, you're like, woo, let me buy more. More people are going to want to buy it. Okay, now we're looking at the supply equation. Suppose the price and supply of strawberries are related by the following. Price equals, this is now supply based on Q, which equals 0.35 Q. Again, you should know this is a supply equation because the slope, the coefficient on Q, is positive. Find the quantity supplied when the price, so we're substituting in for P, $0 and $2.80. Okay, so 0 equals 0.35 Q. Q is 0, right? So 0 quarts. That should make sense, right? If you can't charge for something, who's going to want to make it and sell it? Nobody. I'm not making anything for you people. Okay, and then 280 is our price. So 280 equals 0.35 Q. divide by 0.35, and you should get Q equals 8. So that means the supply would be 800 quarts. Okay, very good. Now we're asked to graph the supply and demand on the same axis. Okay, so let me rewrite the equations down here just so we have them. So demand was P equals 6 minus 0.25 Q. And we had a few points that were going to help us. So we had 0 for Q is $6. And then 4 for Q is $5. Remember, the ordered pairs go Q comma P. And then for supply, let me rewrite the equation. It was P equals 0.35 Q. And then we had 0, 0. And then also we substituted in 280 and we got Q was 8. So 8, 280. That might be a little tricky to graph. Let me do supply in a different color, just so it's very clear on the graph. Okay, so let's make sure here we label our axes so you keep it straight. Q is where the x-axis usually is, and then P is the y-axis, okay? And then Q is going to be in hundreds, so I'm not going to actually plot 400, 800, right? We're going to plot 0, 4, 8, like that. And then the price, this is just dollars, so that's regular. Okay, let's graph the demand equation. So we have 0, 6, 1, 2, 3, 4, 5, 6, and then 4, 5. 1, 2, 3, 4, up 1, 2, 3, 4, 5. So here's my demand equation. Keeps going. Supply goes through 0, 0. And then 8, 2.8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, a little less than 3. Okay. There we go. So supply, demand. Good? Okay, what we're going to do now is talk about this very exciting point right here. Ooh, where they intersect. So moving on, let's talk about equilibrium. When the supply and demand are equal, the economy is said to be at equilibrium. The equilibrium price of the commodity, there's a T missing, is the price found at the point where the supply and demand graphs for that commodity intersect, like we saw up above. The equilibrium quantity is the quantity demanded and supplied at the same point. So we can kind of eyeball from the graph where this would be, but you know, there's probably some error because I had to hand draw it and whatnot. So let's go ahead, let's use algebra to find the equilibrium price for the strawberries in the example above. So you're gonna set demand equation equal to your supply equation. So the demand equation was 6 minus 0.25 Q, and I'm going to set that equal to 0.35 Q. So what do I do? First, I'm going to add 0.25 Q to both sides, and then I have 6 equals 0.6 Q. Divide by 0.6. 6 divided by 0.6, that's just 10. So 10 equals Q. And did we answer the question? No, they want the equilibrium price. So to get the actual price, you could plug it into either the supply or the demand equation. I think supply equation's easier, right? So the price is 0.35 Q. So the price at 10 units, or actually it's 1,000, right? You have to multiply by 100, would be 0.35 times 10, which is $3.50. Does that match with what we graphed up above? Let's go check. Q is 10 and the price is $3.50. Let's see. Q is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, it should have been scooted over a little bit. 350. 1, 2, 3, 50. Okay. So probably this 280 messed it up a little bit. It just needed to be scooted over a wee bit more. But yeah, so you can see algebraically, we have a lot more precision. If you're relying on a graph to find equilibrium, it's not so reliable unless it's a computer generated graph. Okay, so cost analysis. There are two things to consider in the cost of manufacturing an item. There's fixed costs and then there's costs per item. So if you think about it, like say you're setting up a manufacturing warehouse to make something, you have your fixed cost, which is kind of like your upfront one-time fee. And then there's the cost that's required per item, all your materials, your labor, etc. So there's two costs to consider. As an example, let's practice working with this idea. Write a linear cost function for an internet site for downloading music that charges $10 registration fee plus 99 cents per downloaded song. You know, back in my day, we did a lot of free downloading using LimeWire, Morpheus, all those sort of sketchy things. So I didn't even have this set up. Okay, we have this $10 upfront registration fee. That's a one-time fee. Then you're charged 99 cents per downloaded song. So cost is dependent on how many songs you download. I'm going to let X be the number of songs that we download. Then I can write cost as a function of X. You pay that $10 up front, one time only, and then 0.99 times X, 99 cents per song. That's it. There's my linear cost function. Good? Now, in economics, we talk about marginal cost a lot. Marginal cost is the rate of change of cost, C of X, at a level of production X. And it's equal to the slope of the cost function at X. So you could look back at this cost function we just wrote and tell me the marginal cost is 0.99, the slope. It approximates the cost of producing one additional item. So if you have a linear cost function that has the form C of X equals mx plus b, then m represents the marginal cost and b is the fixed cost, okay? This is for linear cost functions. Later we'll look at other kinds of cost functions, but right now we're starting with the most basic kind, which are linear. Now, we're going to talk about a break-even analysis. So let P be the price per unit and X be the number of units sold, demand. The revenue, R of X, is the amount of money that a company receives. So how would you compute revenue? All your income coming in is computed by the price that each item is sold at times however many items are sold. So revenue is a function of X. It's equal to the price times X. All of this we're going to refer to throughout the course, so make sure you get these in memory. Hopefully they make sense though, right? That's revenue. Profit, P of X, is the money a company makes after you pay your costs. So revenue is everything that comes in from all your sales, but profit is your net gain. So you have to take your revenue and subtract the cost function from it. So P of X is R of X minus C of X. This is capital P of X for profit, lowercase p is price. So make sure you're not mixing up capital and lowercase letters. I know so many students have that habit or they write in all caps, but you can't do that right now for this course, okay? I'm so sorry. And then the number of units X at which revenue equals cost is the break-even quantity. And notice if revenue is equal to cost, then your profit is zero. So you're just breaking even. I mean, it's not an ideal place to be, but it's better than being in the negative. The break-even point is the corresponding ordered pair, and it indicates the point of zero loss or profit. Okay? Good. So let's work with some examples so we can solidify these ideas a little bit further. So first one says, suppose that the supply function for walnuts is given by P, which is S of Q, equals 0.25Q plus 3.6. I would know it's a supply equation anyways because the slope on Q is positive. P is price in dollars per pound and Q is the quantity in bushels. Suppose also that the equilibrium price is $5.85 and the demand is 4 bushels when the price is $7.60. Find an equation for the demand function assuming it is linear. Okay, so first I have my supply equation. It tells me price equals 0.25Q plus 3.6. I need to figure out what my demand equation is. So P equals D of Q. What is it? Well, notice here they told me the equilibrium price is $5.85. So that's when supply is equal to demand. And they would have the same quantity, right, at that point. So what I'm going to do is take the supply equation and set it equal to that equilibrium price and figure out what the equilibrium quantity is. So 0.25Q plus 3.6 equals 5.85. Subtract 3.6 over to the other side. And let's see, what do we got? 0.25Q equals 5.85 minus 3.6. This is 2.25 divided by 0.25. Q is 9. Okay, so when Q is 9, the price is 5.85. This is the equilibrium price and quantity. So both the supply and demand equations share this point. They have this point in common. So I know that this point right here is on my demand equation. It's on the line if I were to graph the demand equation. And then they gave me one more piece of info about it, about this demand function. It says the demand is 4 bushels when the price is $7.60. So that means Q is 4 when P is $7.60. So now I have 2 points that are on my demand function. I can go ahead and find the equation. I'm assuming it's linear. Using these 2 points, I can find the slope, and then I can use point slope form to find the equation. Okay, so first let's find slope for our demand function. If you want, we can call this one x1, y1, and this one x2, y2. Okay, so I'll have 7.60 minus 5.85 over 4 minus 9. So 7.6 minus 5.85, that's going to be 1.75 divided by negative 5. And this is negative 0.35. So that's our slope. And then I'm going to put it all together in point slope form. So y minus y1 equals m times x minus x1. And I'll just use whichever point. Let me use 9, 5.85. So y minus 5.85 equals negative 0.35 times x minus 9. So y minus 5.85 equals negative 0.35x plus negative 0.35 times negative 9 is positive 3.15. And then last thing, I'm going to add 5.85. Boom. And I get y equals negative 0.35x. 3.15 plus 5.85 is 9. Okay, so this is my demand equation. However, demand doesn't use y and x's, it uses p's and q's. Okay, so price, you're going to replace y with price, p, and it's always a function of q equals negative 0.35q plus 9. And now we are done. Whew! How was that one? That one was a little spicy. I think that's the spiciest one we've done yet. Okay, let's look at one more example. And we're gonna we're gonna build on the concept of profit and whatnot. Okay. Alberto owns a small publishing house specializing in Latin American poetry. His fixed cost to produce a typical poetry volume is $525. His total cost to produce 1,000 copies of the book is $2,675. His books sell for $4.95 each. So A says find the linear cost function for Alberto's book production. So focus in, they gave us a lot of information here. What do I need to find a cost function? I need the fixed cost, yes, and then the marginal cost. Well, let's see. They literally said it right here. Fixed cost is $525. Did they give me the marginal cost? No, they didn't, those stinkers. They told me the total cost to produce 100 copies is $2,675. Okay, so let's put together what we have, and then we're going to see how we're going to get that marginal cost. I know my cost function is going to equal fixed cost $525 plus marginal cost times X. Yes? Okay. They told me the total cost to produce 100 copies is $2,675. So when X is 1,000, the cost is $26.75. So you could say C of 1,000 is $26.75. That's the same thing as saying the ordered pair 1,000, 2,675 is on the cost equation. Okay. So what I'm going to do is substitute these in so I can solve for M. So 2,675 equals 525 plus M times 1,000. Subtract over 525. So 2,675 minus 525. Let's double check everything. 2,150 equals 1,000 M. Divide by 1,000. M is 2.15. So then we can put it all together and say, all right, this means C of X is equal to 525 plus 215X. Woohoo! There's our cost function. How many poetry books must he produce and sell in order to break even? So remember, break even occurs when your revenue equals your cost. Revenue is, you remember the formula? X times P. X times P. Well, what's the price? I'll remind you. R of X is X times P. P, now we're going to use the 495. So X times 495, it looks better. Let's write 4.95 times X equals 525 plus 215X. Okay, solve for X. I'm going to subtract 215X. And then let's see, this is gone. 4.95 minus 2.15, that's going to be 2.80x equals 525. What an ugly little 2. I'm so sorry. Get it together. Okay, and then dividing by 2.8. I'll write that in for you. Divide by 2.8. Divide by 2.8. And we get x equals 187.5. That's not going to work. So you can't produce and sell a half a book. So we'll just round this up to 188 books. And he won't perfectly break even at this point, but that's as good as we can do. Okay. All right. Last part of this problem. How many books must he produce and sell to make a profit of $1,000? So remember, profit is capital P of X. It's equal to revenue minus cost. And in this case, we want the profit to be $1,000. So we're going to take revenue, which was 4.95x, minus the cost function this time. Cost was 5.25 plus 2.15x. And make sure you guys put parentheses here around the cost function because this minus sign needs to distribute. If you forget that, it's gonna mess it up. So 1,000 equals 4.95x minus 5.25 minus 2.15x. Good? Oh, why did I put 5.25? It's 525. Oh me, oh my. Do forgive me. Okay, let's combine like terms. So I have 1,000 equals 4.95x minus 2.15x. That's 2.8x minus 525. Let me add 525. And this is going to be 1,525 equals 2.8x. Then let's divide by 2.8. 2.8. And what do we get? X equals 1,525 divided by 2.8. 544.643. So let's just round to the nearest whole book. I would say 545 books. Okay, good. So that concludes the lesson. If a lot of these concepts are new for you, you haven't taken any economics, then don't worry. We're going to keep working with them throughout the semester, throughout this course. So you'll get used to the idea of profit, revenue, cost, marginal cost, all of that good stuff. If you've already taken some econ, then hopefully these are a little familiar. So then we're just going to build our math skills to compute more interesting quantities and solve problems. Okay, hope you enjoyed the video. Give it a thumbs up, subscribe if you haven't already. And if you need help with any other math courses, statistics, algebra, whatnot, I have videos on my YouTube channel all organized into playlists. So it should be easy for you to find whatever you need. You can also just search on my channel, whatever topics I've already made videos on. And you can also follow me on Instagram, TikTok, Twitter, Math with Professor V. I'll be back sooner than later. Bye.